Thank you very much. My name is Jason Belk. I am an NSO developer evangelist in the NSO business unit, and I have an exciting announcement to share with you, as well as a live demo walking through one of our learning labs. First, the exciting announcement. I'm thrilled to share that we have a brand new NSO Dev Center. We had done a facelift last year on it, but now we've done a completely revamped experience on our DevNet presence for NSO. We have persona-based content. We have a developer, operations, net DevOps content for podcasts, videos, code snippets, as well as lots of other great materials for you to dig in, and it's only going to get better over time. We've put this up with a lot of time and effort and discussion to make this as great as possible for both new users and existing users to access all of the nuggets that both myself and other members of the team and the community are creating for NSO. One of the neat parts of this new Dev Center is that we have new NSO interactive docs. So we have taken the RESTconf Postman collection that I created about a year and a half ago. I exported it to a Swagger doc, and then we've put it back into that Swagger doc so then you can connect to our NSO reservables, always on sandbox. And that way you can click in the browser, see the API responses, and be able to visualize and just all within the browser see the APIs in action. Really excited to see this, and I hope it'll help new and existing users get started. Also, we have new interactive labs. So we've taken our existing lab content and we have new labs coming. Quarter by quarter, we continue to create new ones to try to add more and more content. And this way you can click in the browser, start the labs, it'll spin up a Docker container in the background, and you can play around with NSO, get started, and follow along with what we're doing here. So what the lab I'll be working with is Learn NSO the Easy Way, which is our main gatekeeping lab to have people get started, and then from there you'll branch out and get started on other labs. But now with interactive labs, you can get started even in the browser, so it's even easier than ever to learn NSO and get started. And now I'll move into a demo. And in this demo, we'll have the following topology within our NSO reservable sandbox. We have a series of iOS XE devices, XR devices, Nexus devices, and an ASA firewall. All that to say is we also have an NSO instance on a jump host that I'll be working with and walking through in an abbreviated manner our Learn NSO the Easy Way lab. And now getting started on our lab. This is our Get Started with Network Services Orchestrated Learning track on DevNet. And you can see we have Learn NSO the Easy Way as the lab that we're going to get started with. And I'm going to start on step 4. The first 3 steps is mostly setting up your NSO, putting your devices in the device list, and then now we get started in terms of exploring the network with the NSO CLI. So I'm going to pull up the terminal, which is on our jump host within the NSO reservable sandbox. And if we look at the history, I've covered the commands that are on steps 1, 2, and 3 in terms of setting up an NSO instance for a local install, turning on that NSO instance, configuring an auth group so we can log into our devices, and then adding all our devices we saw in the topology of our Nexus, iOS XE, XR devices. We give the IP addresses, pointing back to that auth group. I'm just going through quick because these are just all repeated for our different devices. Now I've added device groups, one for each of the device types of iOS, XR, Nexus, and ASA, and then an all device group that has a nested device group for all of those other device type groups. And from there, we connected to the devices, and then we synced from the devices to pull the information from all the devices in our network into the NSO local database. So the first thing I'm going to do is to log into the NSO CLI with the NCS CLI command, and we'll say NCS CLI-C-U admin to say we're using the Cisco style and logging in as the admin user. And we'll say show devices list. And this will show us the IP addresses, the device types, and verify that our devices are in fact unlocked for NSO to then be able to read and write from the devices. So moving back, we're starting step 4 on exploring the network CLI. So we're going now, after we've seen the device list, we are going to look at the device configuration. So we can issue a show running config devices device internet router one config. So this is issuing a command to see the snapshot of NSO's configuration database of what NSO has learned from the network device. In this case, the device is internet router one. And so if I push enter, it will then retrieve all of that configuration data for us, looking at the crypto certs, interfaces, gig 1 through 3, as well as our V2I lines. And if you want to look at just a specific part of the configuration, I haven't logged them into the device. It's just NSO's snapshot of that configuration. We can then say, let's look at just the interface configuration part of that hierarchy. So NSO has a hierarchical configuration within the application, and it gives us a data model that we can interact with and query and look at the different pieces. So we have loopback gigabit, Ethernet 1, 2, 3, and 4. So one really exciting feature for me when I'm working with NSO is also the fact that NSO allows us to have the parsed data of the configuration. So even if the device doesn't support netconf or restconf, the network element drivers parse all that information for us, and then we can query that information, look through the information, programmatically interact with it over JSON and XML because it does all the hard work for us to parse that into the CDB. So we can see we have interface loopback 0 in a JSON format. Even though in this case, we're not using any particular API to gather any data from that device, it's parsing all of that heavy lifting for us. And now moving from step 4 to step 5. So we've read information from NSO. Now we're going to update device configuration. Pulling back our NSO terminal, we're going to make a network configuration change, just a simple VLAN, and then we're going to roll back that change. So first we enter config mode, and NSO has a two-phase commit system when you're making configuration changes, similar to what ISXR has. So first we'll enter configuration mode. We'll tell NSO that we want to configure on disk switch 1. We'll then enter configuration within that device. That's why it says config. And we're going to add a VLAN 42. And then we're going to add layer 3 interface VLAN with a fun description. Thanks, Hank, for this example. I really like it. And then now that we've made a few pending changes to our configuration, let's go to the top of the configuration hierarchy, and we can say show configuration to see that pending commit. What are we going to send to the device if we actually make a commit? And we see we have all that configuration displayed for us. And we can actually do that same command and say pipe display XML if we wanted to see NSO's XML representation of that same configuration. Maybe we were creating a template, which we'll show later on, and we wanted to grab that XML. And that's an easy way just to configure it in a human-readable format using the native CLI. And then you can quickly do pipe display XML to see the machine-readable format. And if we make the change, we type in commit. Behind the scenes, NSO is logging in the device, pushing those CLI and configuration lines line by line, and then verifying that the change was successful. So now that the change has taken place, we can actually now look at what we call NSO rollback. So any change, not just for one device, but maybe across multiple devices, maybe across many changes all within one transaction, we can then ask NSO, what would you do if you wanted to roll back that transaction, those lines of configuration that we just asked you to push? And then calculates for us, this is what we would do to remove. We would say no VLAN 42 to remove the VLAN, and then no interface VLAN 42 to remove the layer 3 interface. And if we actually wanted to roll back that configuration, we simply say rollback configuration. It puts that in our pending commit, and I can say commit dry run, format native to see the lines it would send, just to verify, okay, it's exactly what we thought it was, and then we can commit and we'll pull back the configuration that we were just looking at. While that's committing, I'll move on to our next step. So we have step 6, templates and live status. So within NSO, we use templates to take basically a golden config, say, is this on the device? And if it's not on the device, compare that to what we have in the NSO CDB and then push the difference. Use the minimum amount of commands to make that configuration complete. So first, we need to define that template within the NSO local CDB. So I'm going to copy and paste in these commands. I know it looks like a lot all at once, but it's a lot faster than me typing it all out for this quick demo. Basically, to summarize, we went into the configuration mode. We have devices, And then within the devices hierarchy, we're working with templates, and we've named this template called set DNS server. So the set DNS server template has lines of configuration for our DNS servers. So we have two servers on the 208 IP address range, and we have this template covering across multiple device types. So we're covering Nexus, iOS XE, ASA, and iOS XR. And so basically we tell the template, here we're going to work with a certain NED type, here are the lines of configuration, and then we move on to the next device type. So we have all these different device types all within one configuration. So we can just apply one template to our devices and not have to decide about which device to apply it to. NSO does that heavy lifting for us. And now I've saved that template to our NSO CDB, so now we can use that template to apply it to our devices. I'm going to push enter a few times to clear out from all of that template adding. And now scrolling back up again, I'm adding a line saying devices for our group, all of our devices, apply the template that we just created called set DNS server. So remember that two-phase commit applies the template. So in the background, it says, okay, I've understood what the pending changes. And let's actually do a commit dry run at format native to see the lines of configuration it would push to all of our devices. So if I scroll back up, it's going to push all those templates to all of our devices, and then based on the device types, it will do the right syntax for those DNS servers. So we have iOS XE, XR, Nexus, ASA, all in one template being applied to all of our devices, and it's going to push all these lines just simply from that one command. I'm not going to apply it right now, so we're going to move on to the next one. Device operational state, step 7. So one of the important things in network automation is not only being able to read and write configuration data to your network devices, but be able to query, understand, okay, what's the OS version? And that will possibly make decisions on that information for us to then make different work paths for our automation, as well as doing verification, sending show commands, being able to get operational data back from our devices. So first, I want to mention that when NSO does the sync from, it actually grabs a decent amount of useful information on each device. So if we go back to the enable mode of the NSO CLI, we can see we have show devices, device, disk switch 1 platform, and we have Nexus. We obviously see the OS version and the serial number, so it gives us a lot of useful information there. And if we wanted to see that across all of our devices, we could use a wildcard star, say show devices for any of our devices, and then give me just the version. So we can quickly grab different pieces of information, and this is just being pulled from our CDB that's stored alongside the device info. But if we want to get live info, so we use the exec live status command, and then we say what show command we want to send. In this case, we're sending a show license usage to this Nexus device to get our license information. Maybe we're doing an OS upgrade. We want to see what the status is of the boot flash. And so we can say live status exec any dir. And this will then, that dir command will then get us the boot flash information to see if we have enough space on our device for maybe an OS upgrade. Now let's move on to config compliance reporting. So I'm going to have network configuration compliance, and we're going to cover DNS server configuration, syslog server configuration, and NTP configuration. Moving back to the terminal, we need to create a new template. So we're going to create a new template for compliance check that's going to cover all those different situations of DNS servers, syslog servers, and NTP servers. So we have some overlap from our previous template, but we're covering some new ground as well. So I've created a new template called compliance check. And within that template, we have our different device types of iOS, Nexus, and so on, and then our lines of configuration for DNS server, syslog, and NTP. And we have that for each of the different device types. All that to say is I've covered and all those different configurations for all the different device types, and we can verify saying the show configuration to see the pending configuration for this template. So NSO will store the template in here, and it'll show us the summary based on each of the different device types of our DNS and our NTP and syslog server template. And then we want to create what's called a compliance report. So the compliance report within the NSO CDB, we need to name it. So we're calling compliance check, and we're going to compare that compliance report against all our devices against that device group we created way back when. So now that we've saved the compliance report, we can now exit out of configuration mode, and we have our template set up, and now we can use the compliance report, applying that template to actually run the compliance report. So that command is compliance reports, using the name for our report, compliance check, and we want to outformat in text. There's a couple of different outformat options, but this is going to be the easiest one for us to read. So I'll run it, and I'll log into all the devices, and then tell us where on our server that report is now stored. So I'm going to exit out of the NSO CLI, go back to the Linux terminal, and then take a quick look at that compliance report using the Linux cat command and a wildcard store to see the output of that report. So it says per device name, what lines of configuration are missing, using the plus sign to tell us what lines I would add. It's using the curly bracket notation because behind the scenes, that's how NSO represents configuration. Even if it's iOS configuration, it's going to use this curly bracket notation to represent the different nodes within our database. And now we have the compliance report, and then we can take that to our management, say these are the areas we need to fix, and then schedule our change request to be able to fix it. So finally, I guess second to last, we have NSO services. So what's an NSO service? I'm not going to deep dive on this, but I will say that the NSO service at a high level covers a Yang model, and that Yang is being used to define the constraints of our inputs for our service, our configuration templates. We have some logic, which we're not really going to do in this example. You have some Python or Java. And then you have your XML template. So this is what's being applied to our devices with our inputs to then push configuration to our devices, and NSO maintains that state and then able to re-push the configuration as needed. It has a lot of neat features for that we're not going to focus on today, but I definitely suggest you take a look at on your own. So NSO has a bash utility called NCS make package, and we have -- service skeleton to tell, hey, make a service skeleton within our, I probably should actually change to our packages instance because that's where it's going to be looking for our packages. So I'll make a service skeleton for a loopback service. And we can see within there, we have just our NEDs right now that are the network element drivers that are talking to our underlying devices. And so NCS make package will create a certain amount of skeleton files for us for both Yang and XML. So it creates an XML template skeleton where we would just within this config XML snippet, put in our configuration. And then for the Yang side, has a basic setup where we have a list of devices for our loopback service, and then one variable input for our IP address that we're going to be plugging into our loopback. So now logging back into the NSO CLI, I'm going to make a dummy pending change just so I can get the XML so that I can plug it into our service. So let's say I wanted to make this dummy interface loopback 100, and then we have some basic IP address and subnet mask. I can actually then say show configuration to say, okay, here's my lines of configuration in readable format. And then here we have that same change outformatted in XML, which is what we're expecting to see in that template. So I'll go ahead and copy that configuration template into our XML. And I'm not going to make that change because that was just to get the XML. I'm going to move into my loopback service and compile the Yang because that's one other step we need. And then we'll jump back into NSO and do a packages reload to have it reload that new package, that loopback service that we just created and compile the Yang for. And while that's going, I'll move on to the last step where we have, Step 10, creating a service instance. So within a service instance, we have our service model that we just created for our loopback service, and it's going to apply that XML template to our underlying devices. So we can create a service instance. In this case, we're just adding one device per service instance, and we're going to apply that loopback service based on the constraints of our Yang model inputs and our template. And the template is just the loopback configuration, and the input is just the data model that we define in our Yang file. And while that's reloading, I'd also like to say that the NSO services have a lot of extra neat features where you can add Python logic, Java logic to be able to add verification checks, use those exec any commands that we saw earlier. If you wanted to send show commands, maybe store that in a certain area, or have certain other plugins that call into other sources of truth. So now we're in our configuration mode, and I copy and paste config and a loop back question mark, just like we have in iOS. So you can see that our NSO application has been extended to have our new service, what we call loopback-service. And if we wanted to add that new loopback service, we can copy and paste and call a new service instance called test, and we'll have two inputs of our device name. In this case, we're using dist router 1, and then our IP address that we're going to plug into the loopback of 192.168.1.1. We can then do a commit driver on app format native, and then see here are the lines of configuration, all from one input that we would then push to our device. And that's simply the lines of configuration that we have within NSO, and it's able to calculate what it needs to send. We can commit it, and then it's able to push that configuration to the device. Well, thank you for being with me along the session. I hope you learned something, and as well as you're as excited as I am about the new NSO Dev Center. Thank you,